Find the number of photons emitted per second by a 25 watt source of monochromatic light of wavelength 6600 angstroms. What is a photoelectric current assuming 3% efficiency for photoelectric effect? Let us say N is the number of photons emitted per second, and the energy of each photon would be given by hc by lambda, where h is the Planck's constant, c is the speed of light in a vacuum, and lambda is the wavelength of light, 6600 angstroms here. This is equal to 25 watts. I'll skip the units and I'll keep everything strictly in SI units here. So this becomes N is equal to 25 into the wavelength divided by Planck's constant into the speed of light, or 25 into 6600 into 10 to the power minus 10 meters divided by Planck's constant is 6.6 into 10 to the power minus 34 in SI units, and the speed of light is 3 into 10 to the power 8 meters per second. So we get N is equal to 25 by 3 into 10 to the power 19 photons per second. And now we are asked to calculate the photoelectric current assuming 3% efficiency for photoelectric effect. So what is current? This is equal to the number of photons per second into the efficiency, which is how many photons actually liberate the electrons. So N times epsilon gives us the number of electrons liberated per second multiplied by the electronic charge. This would give us the charge flowing per second, or the current. So this becomes 25 by 3 into 10 to the power 19 into 3 by 100, which is 3% efficiency, into the electronic charge, which is 1.6 into 10 to the power minus 19. 10 to the power minus 19 and plus 19 cancel out. We have a few more cancellations here. So 1.6 by 4 gives us 0.4 amperes. And hence, here option A is the answer that matches with our values. There's one thing to note here, that this joules that they gave here as a units for number of photons per second is clearly a mistake, and it is just supposed to have a units of number of particles or number of photons per second.